today we are going to take what we just did with 5 ways of proving triangles congruent and actually just write it in a proof, which you've almost really been doing, we just haven't formalized it and wrote it down with reasons. So go ahead and pause it and take this down. I'm going to go ahead and show the given because hopefully you know by now that's always the first step. So, and it's already marked on our diagram that RS and TU are congruent, and then RT is congruent to SU. But if it's not already marked, you should probably, you should mark it down on your diagram. So, with that given statement, there's no step that actually formally follows from there. But we're not done with our proofs because we're going to try to prove that triangle RST is congruent to triangle UTS. So hopefully you remember what you can always mark in this type of diagram is our shared side. So that every time you mark something on the diagram, you have to write it as a step. So side ST is congruent to ST, and remember what property that is. It's the reflexive property. So anytime you mark a shared side, you have to write down the step, and it has to be the reflexive property. So now, looking at our proof, do we have enough information to say that those two triangles are congruent? Yes. Triangle RST is congruent to triangle UTS, and taking a look at the reason why they're congruent, it's marked by SSS, side, side, side. So that first proof is done. All right, here's our second one that we're going to practice with. So go ahead and draw this out, get the diagram down. Remember, go ahead and write the givens. It's just me and my preference, I put all the givens in one step, but you definitely need to read through those ones that are fill in the blanks because a lot of times they separate the givens, but I just put it in one step. So once again, they already have this marked in the diagram, but if it was not marked, you always go ahead and mark the given. So step 1's done, let's look at step 2. We're trying to prove these two triangles are congruent, but we only have 2 sides marked. But remember, in this type of diagram, we can always mark the vertical angle. So you mark something, you gotta write it as a step. So this is gonna be step 2, angle BCA is congruent. And remember, if we're doing B to C to A, we have to start from D to C to E because B to C has 1 notch and D to C has 1 notch. So angle DCE, those are congruent. You cannot just write angle C is congruent to angle C because there are actually 4 different angles and we need to know exactly which angles you're talking about. And the reason why we're allowed to mark that is because vertical angles are congruent. I'm just going to abbreviate right there. So now, let me erase the extra things that I've marked. We have our 2 sides from the given, and then we have our vertical from just our knowledge that vertical angles are always equal. So now looking at our diagram, is that enough to say that those 2 triangles are congruent? Sure. Triangle ABC is congruent to triangle EDC. And if we look at the markings, we have side, angle, side. So our reasoning for this is side, angle, side. All right. Moving on to our next proof, go ahead and draw this out. We have some parallel lines now. And write down your givens into your 2-column proof. So now this one, we have one side marked congruent, but another part of the given is this parallel. So remember with our practice, if we have parallel lines, we have angles that we're going to mark congruent. So I'm tracing out my Z. And that shows that these 2 angles are congruent. So if you mark it, you gotta write it. And what I've just marked is angle WXZ is congruent to angle YZX. And why was I allowed to mark that? It's not the definition of parallel, but what type of angle pairs are these? These 2 angle pairs are alternate interior angles. So you can just write alternate interior angle theorem or alternate interior angles are congruent. And I'm just abbreviating here because I'm running out of room. So alternate interior angle theorem means that we can set those 2 equal. So now let's look. We have a side from the given and then we have our angle we just had marked. But we're not done because all we have is a side and an angle. But remember, we can always mark that shared side. So you mark it, you write it, and you have side XZ being congruent to side XZ by the reflexive property. Okay, so now that's all we're allowed to mark. They don't give us anything else. Let's take a look at our order. These 2 triangles are congruent. triangle WXZ congruent to triangle YZX, and that is the order of side, angle, side. Okay? So hopefully you can get the alternate interior angles correct. All right, so now we have several different things happening in the given. It says angle B and angle D are right angles. That's marked on the diagram. Angle A, or sorry, not angle, side AE bisects side BD. Right now, we have nothing that says in our steps that any angle or side are congruent. But it tells us that we have right angles. Well, what do you know about right angles? Okay, if angle B and angle D are right angles, then you know that the measure of angle B is equal to the measure of angle D because those equal 90 degrees. All right, this is a weird step. It's not a property, it's not a definition. We just know that all right angles are congruent. Okay, so this is just the weird one that you'll see over and over. Anytime you see right angles in a given part, you have to follow with step 2. So step 3, now that we know that those are congruent, okay, we're done with this part of the given. The second part of the given says AE, that side bisects BD. So side AE is cutting side BD in half. So I can mark those two there. So remember, you mark it, you write it. Side BC is congruent to side DC. Why was I able to say that those two sides are congruent? What did they tell me in the given? Well, there's that keyword bisects. So once you see that, bisects, midpoint, something like that, it's always the definition of bisects or midpoint or whatever they give you. So that's the reason why I was allowed to say BC is congruent to DC. So I've done both of my givens, but all we have is an angle and a side. So taking a look at this diagram, hopefully you can identify we're allowed to use our vertical angles. So I marked it, I write it as a step. Side angle BCA is congruent to angle DCE. And that's the definition of vertical angles. Okay. All right, so let's take a look at what we've done. This is all that we can mark on our diagram. So now we know we're done with the proof. So step 5 is triangle ABC is congruent to triangle EBC. So you're just rewriting that final proof that they give you up here. Okay, and so now we look at our order. We have angle, side, angle for this proof. Okay, so let's go ahead and take a look. This is more of a longer proof that you'll need to know because it doesn't really give you much, anything congruent yet in the given. So let's go ahead and take a look. Step 1, okay, just rewrite the given. It says JM bisects angle J, and JM is perpendicular to KL. So let's start with the first part of the given. Let's do bisects. If JM bisects angle J, then I know I can mark those two angles congruent. So let's go ahead and we marked it. We have to write it. Angle KJM is congruent to angle LJM. And why was I able to mark those two congruent? Remember that key word up there. The key word says that JM bisects that angle. So this is the definition of angle bisector. Okay? So that takes care of this first part of the given. Gives us those two angles congruent. Let's take a look at the second part. It says that JM is perpendicular. Now yesterday I said that there's always two steps that follow perpendicular. So if you remember it, great, but now you have to memorize it. Step 3 is the first one. Now that we know it's perpendicular, we're allowed to say that these are right angles because that's what perpendicular means. We can say angle LMJ and angle KMJ are right angles. Now what told us that I could say that those are right angles? Well, they give us that symbol there, which is perpendicular. So this is the definition of perpendicular. Right? So that's the first step that always follows when you see perpendicular in your given. So now we have to say, we say that they're right angles, but we haven't said that they are congruent. Well, what do you know about all right angles? They're congruent. So now we can state after that step that angle LMJ is congruent. I'm sorry, the measure of angle LMJ and the measure of angle KMJ, they're congruent and they equal 90. Remember that reason we just did on the prior proof was all right angles are congruent. Okay, so I'm just going to abbreviate. These two steps, okay, always follow the symbol perpendicular. They have to be in your proof, both of them, or it's wrong. Okay, so now we took care of that. So we have two angles marked congruent on our triangles. We're not done, okay, because all we have is angle. So let's take a look. Hopefully you can recognize we have the shared side again. So we can state JM is congruent to JM. And that property is, once again, reflexive property. All right, almost done. Here we go. That's all we can do. So let's finally say what we're supposed to prove, that these two triangles are congruent. Triangle JMK is congruent to triangle JML. And let's take a look at the order. The order of the triangles that we have marked is angle, side, angle. 6-step proof. That's probably one of the longest you'll have to do in this class. All right, so this one I want you guys to actually do on your own. So pause it, write it through, make sure you're marking on the diagram, and then I'm going to show you all the answers and the steps you should have. All right, here we go. Let's take a look to see if you got this right. So you have midpoint. So since you have midpoint, this step right here has to be included. You can't just jump right down to BD is congruent to BD. Because you're marking this up here, remember you mark it, you write it as a step. So this is by side, side, side. Hopefully you did pretty well on this. All right, this is our last proof for the day. So go ahead and draw this out. We have a lot of things going on. We have 3 different things in the given. And once again, I just put them all in one line. You don't have to. You can separate 1, 2, 3. That's fine as long as you're writing given for all the reasons. So this is our mountaintop looking diagram. And once again, they have parallel lines. So once we have the parallel lines, I hope you remember it's the angles that are attached to those. So we have angle, remember we mark it, rewrite it. Angle VZY is congruent to angle UXW. And hopefully you remember the reason. Since it's parallel, it's an angle reason, and these are corresponding angles. Okay? Or the corresponding angles theorem. I'm running out of room, so I'm just going to put corresponding angles theorem. All right, so that was that was this part of the given. That set of parallel. I jumped over and skipped the first one, because I just saw these first. Okay, but if we go back, here is VY and WU, and these two are connected, these two angles, to that side. So since we marked it, we write it. Now you could actually include this in step 2 or make it its own step because the reasons are the same. It is corresponding angles. I'll just do another step, step 3 using this. Gives me angle VYZ congruent to angle UWX. And once again, that's from the corresponding angles theorem. All right, so we have that all marked with our angles, and then just in the given, it tells us that WX is congruent to YZ, so there's no extra step that we have to write there. So now we do have enough information to say that triangle WXU is congruent to triangle YZB, and that reason, if we look at our markings, is angle, side, angle. We are done with proofs. So make sure you're only marking what they tell you to mark and you're writing those steps down correctly and giving the right reasons.